One. Hi everyone, my name is Vikas. I am from CSC AML section D. I select the topic I select the topic in engineering chemistry, dielectric breakdown process of polymers. Introduction to dielectric breakdown of polymers. Dielectric breakdown is a failure mechanism where an insulating polymer suddenly becomes a conductive under high electric stress. Polymers are widely used as electric insulators due to their excellent dielectric properties. Understanding the breakdown process is essential for improving polymer insulation performance and reliability. There we can see the image behind the topic. Electrical breakdown of dielectric breakdown. Electrical breakdown means a failure of insulation, small voltage, insulating medium tolerate, no breakdown. And this is the first slide. And the second slide is the basic principles of dielectric materials. Dielectrics are materials that do not conduct electricity but can support an electric field. The insulating ability of polymers depends on their molecular structure and purity. When the electric field exceeds a critical value, breakdown can occur, leading to electrical failure. We can see dielectric constants and the dielectric strengths of various materials at room temperature. Material dielectric constant K, dielectric strength V by M, vacuum 1.0000, dielectric strength is minus air 1.00059, 3 into 10 power 6, bakelite 4.9, 24 into 10 power 6, fused quartz 3.78, 8 into 10 power 6, Pyrex glass 5.6, 14 into 10 power 6, polystyrene 2.56, 24 into 10 power 6, Teflon 2 power 1, 2.1, 60 into 10 power 6, neoprene rubber 6.7, 12 into 10 power 6, nylon 3.4, 14 into 10 power 6, paper 3.7, 16 into 10 power 6, strontium titranate 233, water 80, silicon oil 2.5. And this is the basic principle of dielectric materials. Dielectrics are materials that do not conduct electricity but can support an electric field. The insulating ability of polymers depends on their molecular structure and purity. When the electric field exceeds a critical value, breakdown can occur, leading to electrical failure. And these are the basic principles of dielectric materials. Type of dielectric breakdown in polymers. Intrinsic breakdown involves the direct ionization of molecules within the polymer. Thermal breakdown results from localized heating causing material degradation. Electrical treeing is a progressive process involving the growth of branched microchannels leading to failure. And these are the type of dielectric breakdown in polymers. I will explain more. Or intrinsic breakdown involves the direct ionization of molecules within the polymer. Thermal breakdown results from localized heating causing material degradation. Electrical traying is a progressive process involving the growth of branched microchannels leading to failure. And we can see behind the slide of the image, and we can observe the diagrams, and we can observe the degrees of how the diagram will going on. And then this is the types of dielectric breakdown in polymers. Next, mechanism of breakdown: electron impact ionization. Electric fields accelerate electrons which collide with the polymer molecules. These collisions generate free charge carriers that amplify the local field. Once a critical number of free carriers are represent, catastrophic breakdown occurs. And this is the mechanisms of a breakdown electron impact ionization module. We can see modules. The module one, concentration and breakdown in a generous dielectric. Module two, concentration and day breakdown in invalid and a squared dielectric. Module three, generation of high voltage and currents. Measurements of high voltage and currents, module 5. And these are the non-dielectric treating of electrical apparatus. Next, role of microstructure and defects. Microstructural features such as voids, cracks, and impurities acts as initiation sites for breakdown. Defects creates localized regions of high electric field intensities. Improving the purity and uniformity of polymers enhances dielectric strength. And I will also read second time because of you can understand the role of microstructure and its effects. Microstructural features such as voids, cracks, and impurities acts as initiation sites for breakdown. Defects create localized regions of high electric field intensities, improving the purity and uniformity of polymers enhances their dielectric strength. Thermal effects and breakdown. Excessive electric stress can cause localized heating within the polymer. Thermal aging. Excessive, and now I will read the second time. Thermal effects and breakdown. Excessive electric stress can cause localized heating with the polymer. Thermal aging weakens the polymer's molecular bonds, promoting breakdown. Proper thermal management and material selection can mitigate thermal breakdown. And these are the thermal effects and breakdown. Excessive electric stress can cause localized heating with polymer. Thermal aging weakness the polymers molecular bonds promoting breakdown. Proper thermal management and material selection can mitigate thermal breakdown. Electric traying phenomenon. Electrical trays are branched tree-like channels that develop within the polymer under high voltage. They grow slowly and can eventually connect electrodes, leading to failure. The process is influenced by the polymer's dielectric properties and environmental conditions. Electrical traying phenomenon. Electrical trays are branched tree-like channels that develop within the polymer under high voltage. They grow slowly and can eventually connect electrodes, leading to failure. The process is influenced by the polymer's dielectric properties and environmental conditions. Factors influencing dielectric strength of polymers. The magnitude and the duration of the applied electric field significantly affect breakdown. And we can see the strength, how the polymer, how the dielectric strength will be, and the wires in between that soldering. We can see that the environmental factors like humidity and temperature also play a role. Material modifications such as adding fillers or stabilizers can improve dielectric strength. And these are the factors influencing dielectric strength of polymers. The magnitude and the duration of the applied electric field significantly affect the breakdown. Environmental factors like humidity and temperature will also play a role. Material modifications such as adding fillers or stabilizers can improve dielectric strength. And we can see the next slide. Testing and measurement of breakdown strength. Common tests includes AC and DC breakdown voltage measurements. Samples are subjected to increasing voltage until failure occurs. Data from these tests help in designing more reliable polymer insulators. Improving dielectric breakdown resistance. Incorporating nanofillers can enhance the polymer's resistance to breakdown. Process cross-linking and chemical modifications improve molecular stability. Proper processing techniques reduce defects and microvoids that initiate breakdown. And the next slide, applications and practical consideration. Polymers are used in cables, capacitors, and electronic devices requiring high dielectric strength. Long-term electrical stress and environmental exposure must be considered in design. Advances in polymer technology aim to develop more robust insulating materials. And the last side references are there, and you can see the references. The third edition Village 2006. Thank you.